Hello, we are going to go over the Chapter 8 practice test answer key, so let's get started. Number 1 is under the learning target. I can factor monomials and find their GCF. So number 1 says list the prime factorization of negative 34ab cubed. So I'm going to go ahead and make a factor tree for negative 34, and when I do that I'm actually going to take out a negative 1 to begin with, and I know a negative 1 will be in my answer. But I'm going to go ahead and break down now positive 34. That will break down into 2 and 17, and then 2 and 17 don't or can't factor anymore, so my final answer will be negative 1 times 2 times 17 times A times B times B times B. Number 2 says find the GCF of 44y cubed and 80xy. So I'm going to go ahead and figure out what 44y cubed breaks down into, and then I'm going to go ahead and see what 80xy breaks down into. So I'm going to go ahead and put 44 right here, break it down. 44 breaks down into 2 and 22, and then 22 breaks down into 2 and 11, and then that is actually complete. I can't break down any further, so I get 2 times 2 times 11 times y times y times y. And then I'll go ahead and break down 80, and 80 breaks down into, we could do 8 and 10, and then 8 breaks down into 4 and 2, and then 2 and 2. 10 breaks down into 5 and 2, so 80xy breaks down into 2 times 2 times 2 times 2, so 4 of them, times 5 times x times y, and then we can go ahead and see what the two have in common. So I'll grab my highlighter here, and they both share 2 and another 2 and a y, and that looks like that's everything that they share in common. So I'll write out my final answer, and the GCF of these two monomials would be 4y, because 2 times 2 is 4, and then they only share a variable of y. Alright, the next learning target is I can use a distributive property and factor by grouping. So number 3 has 3 terms, so that should tell us we are going to use the distributive property here to factor. And I'm going to go ahead and look at those 3 terms and take out the GCF. The GCF of those 3 is 7xy. And now I draw in my parentheses and I'll undistribute. So I'll say, oh, if I start at 7xy, how do I get to 14x squared y squared? And that will be 2xy. And then I ask myself, if I'm at 7xy, how do I get to negative 21x squared y? And that would be a negative 3x. And then if I'm at 7xy, how do I get to 35xy squared? That will be a positive 5y. Then I could check my answer by go ahead and using the distributive property and asking myself, is 7xy times 2xy give me 14x squared y squared? It does, and I could go ahead and do that for each term. And that is my final answer. Alright, number 4 has 4 terms, so that should tell us that we need to use factor by grouping to factor here. And so my first thing I need to do in factor by grouping is I need to look at the terms and see if I should regroup. These look okay to me. I'm going to leave them as they are and go ahead and factor. So I break them up into 2 groups of 2, and then I look at 8ac minus 2ad, and I take out the GCF, and the GCF is 2a. And now I undistribute, so if I'm at 2a, how do I get to 8ac times 4c? If I'm at 2a, how do I get to negative 2ad times a negative d? And then I look at the second set, now of 4bc and negative bd, and I take out the GCF of those terms, which is a b. Now I undistribute, so if I'm at b, how do I get to 4bc times 4c? If I'm at b, how do I get to negative bd? A negative d. And now I go ahead and look at and see if I have the same factor in my parentheses or an additive inverse, and I have the same factor. And then I go ahead and put my terms that are outside of my factor together. So I'll put 2a plus b together, and that will combine for one factor. Then my other factor is 4c minus d. And then to check my answer, I could go ahead and FOIL. I'm going to circle my answer here, but I'm going to go ahead and FOIL to make sure I get what I started with. And 2a times 4c is 8ac. 2a times negative d is minus 2ad. And then I have b times 4c, which is 4bc. And then b times negative d, which is negative bd. And so I get what I started with when I FOIL, so I know my answer is correct. All right, the next learning target is I can factor and solve quadratics in the form of x squared plus bx plus c equals 0. So it's really important here that we read the directions, and either we're going to just factor or we're going to solve, which means we are factoring and then using the zero product property to actually set our factors equal to 0 and find the solutions. And then if you notice in this learning target, it says x squared plus bx plus c, which means we are going to use the diamond method because there is a 1 for coefficient in front of x squared. So let's look at number 5 here. Number 5 says factor x squared plus 15x plus 36. I'm going to use the diamond method again because a 1 is in front of x squared for the coefficient. And I'm going to put c on top, which is 36 here, b on the bottom, which is 15 for the coefficients again of 15 would be b and c would be 36. And so I ask myself, what are the factors of 36 that when added together give me 15, and those are 12 and 3. So then I write my factors as x plus 12 times the quantity x plus 3. And again, a way I can check my answers is by going ahead and foiling those. And so x times x would give me x squared. X times 3 gives me, I can write this out here, x squared plus 3x plus, and then 12 times x is 12x. 12 times 3 then is 36. Combine my x terms there to give me 15x, and I get what I originally started with. So x plus 12 times x plus 3 is my final answer. All right, number 6 says solve x squared plus x equals 42. So the first thing that I would need to do here is get my equation equal to 0. So I'm going to subtract 42. So I essentially move it to the other side and get x squared plus x minus 42 equals 0. And then I'm going to use the diamond method to factor here because 1 is the coefficient in front of x squared. So I'll say factors of negative 42. That when added together give me 1. Again, my c term goes on top, my b term goes on bottom. And I'm going to go ahead and ask myself, factors of negative 42, that when added together give me 1. That would be 7 and negative 6. So I write my factors as x plus 7 times x minus 6 equals 0. Then again here I set both factors equal to 0. So x plus 7 equals 0, x minus 6 equals 0. And then I subtract 7 here. And I get x equals negative 7, add 6 on to this factor here, so x equals 6. So my two solutions, can put them in bracket form, are negative 7 and 6. Now again, a way I could check my answer here is I could go ahead and plug in these answers into my original equation, and if they satisfy the equation, then I know I am correct. The next learning target is I can factor and solve quadratics in the form of ax squared plus bx plus c equals 0. So if I see ax squared, and that should give me a hint that a perhaps here would not be 1, it would be something other than 1. So that should remind you to use the snowflake method. And let's take a look at number 7. So number 7 says factor 2x squared minus 11x plus 15. So I can leave my answer in factored form. So I'm going to go ahead and draw in my snowflake. And on the top of my snowflake goes a times c. Again, a is 2, b is negative 11, c is 15. So up on the top of my snowflake, 2 times 15 is 30. On the bottom, my b term is negative 11. And then a goes in the top two positions. And then I ask myself, what are the factors of 30 that when added together give me negative 11? That would be negative 5 and negative 6. And then before I write my factors, I look at my two fractions on the side and I see if I can simplify those. And I can simplify 2 over negative 6 to 1 over negative 3. So when I write out my factors, they go as follows. 2x minus 5 from right over here. And then this second factor comes from right here, which is x minus 3. And again, I can check my answers by going ahead and FOILing 2x minus 5 times x minus 3. So if I do that, 2x times x is 2x squared. 2x times negative 3 is negative 6x minus 5x, and then plus 15. Let's fix that. Plus 15. Combine my negative 6 and negative 5x, and that gives me negative 11x. So I do in fact get the original expression. So I was correct in my answer of 2x minus 5 times x minus 3. Number 8 says solve, so I know that I'm going to first try and get my equation equal to 0. So I'm going to add 32x to the other side and get 8x squared plus 32x plus 24. So making sure I again equal 0, put them in descending order. So A is 8, B is 32, and C is 24. And I know I'm going to use the snowflake method to factor because 8 is in front of x squared. But before I do that, I actually want to take out a GCF here of 8. So I'm actually going to erase A, B, and C, right, because those could perhaps change. So if I factor an 8 out, I then get x squared plus 4x plus 3 equals 0. So I'll just have to put that GCF of 8 in my ending answer, and then actually A is 1, B is 4, C is 3. So I don't have to use the snowflake method because A is 1, but I'm going to go ahead and use the diamond method. So C goes on top here again, which is 3, B on the bottom 4. So you ask yourself, what are factors of 3 that when added together give you 4? 3 and 1. So I would write out my factors as x plus 3 times the quantity x plus 1. And I can't forget the GCF of 8 that I factored out. Set that equal to 0. Here that 8 doesn't matter because it doesn't have a variable attached to it, but I'm going to set x plus 3 and x plus 1 equal to 0, and those will tell me my solutions. And I subtract 3 here and get x equals negative 3, subtract 1 and get x equals negative 1. And my two solutions here are negative 3 and negative 1. And then again, because I solved these, I should be able to plug these into my original equation, which I'll draw an arrow here, it's right up here, and that should satisfy the equation and work, and it will if you plug those back in, which you should do on your test. The next learning target is I can factor special products. So let's look at number 9. Directions say to factor, and number 9 is a difference of squares, because I can take the square root of 4x squared and 81, and then there's a subtraction sign in between. So this is going to factor into two binomials that are almost identical. One will have a plus sign, one will have a subtraction sign. So I'll take the square root of 4x squared and get 2x, and that will go in the first position of both binomials. Square root of 81 is 9, that will go in the second position, and then they just differ in that one's a minus and one's a plus. And then to double check my answer, I could go ahead and FOIL and make sure I get what I started with, or the expression that I was given. And if you FOIL, you will, in fact, get 4x squared minus 81. All right, number 10 has 4 terms, so this is another factor by grouping problem. And so the first thing I'm going to look at with factor by grouping is perhaps if I should rearrange them or keep them as they are. I'm going to keep them as they are. So I'm going to group the first 2 together and group the last 2 together. And I'm going to look at 3x cubed plus 2x squared and take out a GCF of x squared, undistribute, and if I'm at x squared, how do I get to 3x cubed times 3x? If I'm at x squared, how do I get to 2x squared plus 2? And then I look now at the second set of negative 48x minus 32. I'm going to take out a GCF of negative 16 undistribute, and if I'm at negative 16, how do I get to negative 48x times 3x? If I'm at negative 16, how do I get to negative 32? Positive 2. And I go ahead and look at my two factors and either hope they're identical or additive inverses, and they are identical. And then I put together the other terms that are outside the factors together. So I'm going to get x squared minus 16 times 3x plus 2. I'm almost done, but if you notice here with the x squared minus 16, that can actually continue to factor because that's the difference of squares. So that factors into two binomials that are almost the same. So I'm going to take the square root of x squared and get x, take the square root of 16 and get 4, and one will be a positive and one will be a negative. And then I keep 3x plus 2 as it is because nothing will change with that. And then I could also get my original 4 terms that I started with by going ahead and multiplying those binomials together. And we will, in fact, get what we started with. All right, number 11 says find an expression for c that will make 25x squared minus 60xy plus c a perfect square trinomial. Okay, so if we go ahead and draw our two binomials, we know that these two binomials will multiply to be our trinomial of 25x squared minus 60xy plus c. We know the first position in each binomial will be the square root of 25x squared, which will be 5x. And we know that we have a subtraction sign for our middle term here of negative 60xy. So these terms here will both be negative, both subtraction signs. And for a perfect square trinomial, remember that we take 2 times the square root of our first term, which is 5x, times the square root of our last term, which we don't know, to equal negative 60xy. So 2 times 5x is 10x, and we need that times something to equal 60xy. Well, 10x times what will give me 60xy? What about 6y? So 6y times 10x will give us 60xy. And again, we also had to multiply by 2, which we did. And so this last term here in our binomial will be 6y and 6y. So actually to get c, I would have to, FOIL these two binomials, and 6y times 6y actually gives me 36y squared for c. And that is my final answer. I should also say with 11 that we need those terms to multiply to be negative 60xy right here, but because we already took care of the negatives with our binomials right here and here, we didn't necessarily have to worry about that, but we covered that when we put our subtraction signs in our binomial. All right, the next learning target is I can factor and solve special products. So number 12, the directions say to solve. And I'm going to go ahead and look at that equation and move the 16x over because I want to get that equation equal to 0. So add 16x to both sides and get x squared plus 16x plus 64 equals 0. And again, this is under the special products learning target. So hint, we should be able to solve these equations, a little bit simpler than some other ones we have done before. So I look at this and I realize that x squared plus 16x plus 64 is a perfect square trinomial. And it's a perfect square trinomial because I can take the square root of my first term, which is x, times the square root of my last term, which is 8, times 2 to give me my middle term of 16x. So this factors into two binomials that are the exact same. So I get x plus 8 times x plus 8 equals 0. And when I solve that and set that equal to 0, I really only have to set one of them equal to 0 because they're the same answer. So I get x equals negative 8. And I get that answer twice, but I do not have to write it down twice. I can put it in bracket form, and I get negative 8 for my solution. Okay, number 13 also falls under the same learning target of factoring and solving special products. And it's still under the directions of solve, so I need to go ahead and factor and then set my factors equal to 0. And 13 is actually a difference of squares because I can take the square root of my first term and my last term. So I'm going to draw two binomials, and only difference is one will be a subtraction sign, one will be an addition sign. And square root of 9x squared is 3x. Square root of 121 is 11. And then I have to set those equal to 0. So I'm setting both equal to 0. And if you'll notice here, you'll actually get the same numerical answer. It will just differ by the sign. So one will be positive, one will be negative. So I'll add 11, get 3x equals 11, divided by 3. So I get x equals 11 thirds right there. Subtract 11, and then get 3x equals negative 11. Divide by 3. So x equals negative 11 thirds. So my answer here would be 11 thirds and negative 11 thirds. And again, I could check my solutions here when I solve by plugging my answers back into the original equation that was given. Number 14, if you notice, the degree is x to the fourth, so we should actually have 4 solutions to this equation. So let's make sure when we're done that we do in fact have 4 solutions. Of course, unless it is a perfect square trinomial, in case that we'll get an answer that will work double. But let's look at number 14. So I'm first going to get this equal to 0. So I'm going to add 1024 to both sides. And I get x to the fourth minus 80x squared plus 1024 equals 0. Since a, the coefficient in front of x to the fourth, is 1, I'm going to use the diamond method to factor, and a is 1, b is negative 80. Let me write that a little bit better. b equals negative 80, and c equals 1024. And I'm going to ask myself, what are the factors of 1024? That when added together, give me a negative 80. And those factors are negative 64 and negative 16. So now when I write my binomials, I don't just write x times x in the first spot, I write x squared times x squared because I need to get x to the fourth. And then my factors are minus 64, minus 16. Now, actually, both of these factors we see are difference of squares because I can take the square root of my first term and the square root of my last term. So this first one, x squared minus 64, breaks down into x minus 8 times x plus 8. And then this second one, x squared minus 16, factors into x minus 4 times x plus 4. So the 4 factors that I'm going to set equal to 0 and solve, I'm going to set x minus 8 equal to 0 and solve, x plus 8 equal to 0 and solve. I'm going to set x minus 4 equal to 0 and solve, and x plus 4 equal to 0 and solve. And so my 4 solutions that I get to this equation, I'll put them in bracket form, are negative 8, positive 8, negative 4, and positive 4. And I did, in fact, end up with 4 solutions, and I could check to make sure that I am right by plugging them back in to my original equation and making sure that they satisfy that, which they will. Number 15 is under the learning target. I can factor completely to solve. So not only maybe we'll factor once, but we could perhaps maybe factor again. So let's look at 15 and factor completely. Just have to factor, not solve, but I noticed between 32, 112, and 98 that I can factor a GCF of 2 out. So if I factor a 2 out, then undistribute. 2 times what gives me 32x squared? 16x squared. 2 times what gives me negative 112x? A negative 56x. 2 times what gives me 98? A positive 49. Then if we look at 16x squared minus 56x plus 49, that actually is a perfect square trinomial because the square root of my first term is 4x times the square root of my last term, which is 7, times here, in this case, it's a negative 2 because my middle term is negative. So 4x times 7 times negative 2 is negative 56x. So that's a perfect square trinomial. Again, that's quicker to factor than having to use the snowflake method, but the snowflake method would work in this case as well, too. And then the square root of my first term, 16x squared, is 4x. Square root of my last term of 49, which is 7 and 7. And then again, because my middle term here is negative, both factors have to be negative. And again, I could go ahead and multiply 4x by minus 7 times 4x minus 7, and then times 2 and get what I started with, and I will, so I am correct. Number 16 also is under the learning target of factor completely to solve. And don't have to solve here. Again, this is under the same directions as factor, and there's no equal sign, so I don't have to solve quite yet, but perhaps at the next couple problems I will, which I will. So let's look at this first problem, and I look at these three terms of 8x cubed plus 20x squared minus 168x, and I see a GCF of 4x that I can take out. So if I undistribute, I then get 2x squared plus 5x minus 42, and then I look then at 2x squared plus 5x minus 42, and I can, try to continue to factor that. And I'm going to use the snowflake method here because a is 2, so a is 2, b is 5, and c is negative 42. So up on the top of my snowflake, I have 2 times negative 42, which is negative 84, 2 and 2 on the top two positions, and then 5 on the bottom. When you ask yourself what are factors of negative 84, that when added together give you 5, 12, and negative 7. So again, I look at my two side fractions of my factors and see if I can simplify. 2 over 12 simplifies to 1/6. 2 over negative 7 cannot be simplified. So my factors are, and I'm not going to forget to write this 4x in my answer, 4x times x plus 6 times 2x minus 7. And that is my answer. Okay, number 17, the directions above it say factor completely to solve, and we are still under the learning target of I can factor completely to solve. So same directions here. So first thing I notice here with this equation is that I need to get it equal to 0. So I'm going to add 27 to both sides, and I get 48x squared plus 72x plus 27 equals 0. I notice that I'll have a GCF of 3. So I'm going to factor 3 out and undistribute and get 16x squared plus 24x plus 9 when I undistribute equals 0. And then, if you notice, 16x squared plus 24x plus 9 is a perfect square trinomial. And the reason it's a perfect square trinomial is because I can take the square root of 16x squared and get 4x times the square root of 9, which is 3, times 2, and that gives me 24x, which is the middle term. So I can write down 3 again, put in my two binomials. They're going to be the exact same, and the square root of 16x squared is 4x, square root of 9 is 3, and then since my middle term is positive, they're both going to be with plus signs, addition signs, and then I'm going to set my two factors here equal to 0, and it's the same factor, so I only really need to do that once, and set 4x plus 3 equal to 0, subtract 3, and then divide by 4, 4x equals negative 3, divide by 4, so x equals negative 3/4. Again, I could put that in brackets if I wanted, and that is my solution. Now, I didn't have to do anything with this 3, set that equal to 0, because there is no variable with that 3, that's why. And again, go ahead and plug negative 3/4 back into your original equation. Make sure it satisfies that equation and that it will work, and it will. Number 18 has the same directions as number 17 of factor completely to solve. So let's look at 18, and I see that the degree here is 3. So I should have 3 solutions when I'm done with this problem, so let's make sure that we will have that. And I'm going to look at this trinomial. It's set equal to 0 already, so I don't have to worry about that. But what I do notice all three terms have in common is an x. And then since it begins with negative 5, x cubed, I'm going to take out a negative x to get rid of the negative sign. And then if I undistribute, I get 5x squared minus 18x minus 8 equals 0. And now I'm going to use the snowflake method because 5 is it's something other than 1. And I'm going to go ahead and draw on my snowflake. And then on the top goes AC. 5 and 5 I'll put on the sides. And 5 times negative 8 is negative 40. B on the bottom is negative 18. So you ask yourself, what are factors of negative 40 that when added together give you negative 18? They are 2 and negative 20. And then you look at your two fractions and you simplify those, and you can simplify 5 over negative 20 to 1 over negative 4. So I'll write my factors here as negative x that we factored out, that GCF right there, times 5x plus 2 times x minus 4 equals 0. And then I'm going to set all three of those factors equal to 0 because that negative x we took out is a variable. So I'll say negative x equals 0, 5x plus 2 equals 0, and x minus 4 equals 0. And then my three solutions, that one will be 0. This one will be negative 2/5 if we work that equation out. And this one here will be positive 4. So I get 0, negative 2/5, and 4 for my three solutions. Again, I can plug them back into my original equation and make sure that they work out, which they will. The next learning target is I can solve application problems. Let's look at number 19. Number 19 says each football game begins with a kickoff. The formula h equals negative 16t squared plus 64t, where h is the height in feet of the football at t seconds, can be used to model a kickoff that is in the air for 4 seconds. At what time or times will the kickoff be 64 feet above the ground? So in order to first, solve this application problem, we need to know what we're plugging in and what goes where. We are going to set h equal to 64. The reason we want to do that is because we want to know when that football or kickoff will be 64 feet above the ground. So we're going to set h equal to 64. So what that will look like is 64 equals negative 16t squared plus 64t. Now, this is a quadratic equation that we need to solve because we want to figure out what's the time, what's t, when the football is at 64 feet above the ground. So in order to solve this, we have to get this equation equal to 0. So I'm going to move that 64 over and get 0 equals negative 16t squared plus 64t minus 64. Again, I move that 64 to the other side of the equation. Now let's factor, and I'm going to take out a GCF of negative 16. So I get 0 equals my GCF of negative 16 times t squared minus 4t plus 4. And now I'm going to continue to factor t squared minus 4t plus 4. And that's actually a perfect square trinomial because the square root of t times the square root of t squared, which is t, times the square root of 4, which is 2, times negative 2 equals negative 4t. We could also use the diamond method and say factors of 4 that when added together give you negative 4, but again that will give us negative 2 and negative 2 for our factors. So negative 16 was a GCF I took out, and that factors into t minus 2 times t minus 2. Again, we could have used the diamond method or realize that that's a perfect square trinomial, that t squared minus 4t plus 4. So what I need to set equal to 0 is t minus 2, and t minus 2, because this negative 16 doesn't have a variable, and t minus 2 are the same thing, so I only have to set one of those really equal to 0. And when I solve for t, I add 2. So time equals 2 seconds, and that is my solution. And if you think about it, that makes sense. At what time will the football be 64 feet above the ground? At 2 seconds, which means 64 would be at its highest peak. So t equals 2 seconds is my final answer. Number 20, the last problem on our practice test. It says the volume of a box is 192 cubic inches. The height is 4 inches. The width is 2 inches more than the length. Find the missing dimensions. So let's make sure, that we can draw a picture first here. So if I draw my box like this, get that box drawn as best I can here. I'm going to do some labeling of sides. And I know that the height is 4, so I could label my height right here of 4. The width is 2 inches more than the length, so if I call, my length x, I just have to let's call this x here. Now let's call the width 2 inches more than the length. Then the length would be x plus 2. So I got length, width, and height all given a value for. Now, to find volume is length times width times height, and I know all the dimensions of this box, so I'm going to go ahead and say my length times my width times my height, and again, no particular order doesn't matter, equals 192. Now let's do some multiplication. Let's multiply x times x plus 2, and I get 4 times x squared plus 2x equals 192. Again, I distributed that x right there. And then let's go ahead and distribute that 4 to each term. But, if I really don't want to do that, I can kind of just notice that, hey, 4 is being multiplied by x squared plus 2x, so instead of distributing it and then later trying to factor or get rid of that 4, let's just divide by that right away to get rid of that on both sides. And then when I divide by 4, I'm just left with x squared plus 2x, and 192 divided by 4 is actually 48. Now this is a quadratic equation that's a little bit easier to solve. I'm going to bring the 48 over and get x squared plus 2x minus 48 equals 0. I'm going to use the diamond method to factor because a is 1. I'm going to find factors of negative 48 that when added together give me 2, which are 8 and negative 6. So my factors are x plus 8 for my factors or answers, times x minus 6 equals 0. But I need to solve these here because I want to know what that missing dimension of the box is. So if I set x plus 8 equal to 0 and x minus 6 equal to 0, my answers will be negative 8 and 6. If I needed a dimension, or some type of length for a box, which one doesn't make sense? The negative 8 doesn't make sense because we can't have a negative distance, so 6 will work. So if 6, let me go back up to our box here, is our length here, so that's 6, x is 6, what's then 6 plus 2? Well, that's going to be 8. So the dimensions of my box are 4, 6, and 8. So I can write that a little bit neater over here. So I can write dimensions, E-N-S-I-O-N-S, dimensions are 4, 6, and 8 inches. And that is my answer. Now we just went through all of the answers to our practice test, Chapter 8 practice test, and the last thing we didn't necessarily talk about here is just be ready for a bonus on test day. So I hope this was helpful and you were able to get some of your questions answered. And remember, you can always still ask Miss Rowdy for help if you need that before your Chapter 8 test. Good luck on it. You will do great.